A Meccano Obstacle game. This is a detailed description of the model. So these strips along here are the obstacle track, and they're joined by angle brackets on the strips, and then fish plates underneath to join each one, loosely bolted. You can just about see some of the obstacles in here. This is the car, though it doesn't look much like a car, so it has to be fairly specially shaped so that it doesn't jam on anything. But effectively, when that touches the rod behind, it forms a contact and operates a latch relay to permanently switch the machine off, and that's end of game. Over this side here you might see this, and this is actually activated at the moment. So when the game has to go into play, we need the track at a certain position before we actually start to set off, and this is the stop switch for that, and that only works when the thing's in reset mode, not in play mode. Here's the steering wheel, and you can see it moves the car from side to side. Now we've got to be careful of kids who are going to get a bit overly enthusiastic, so the only real way to do it is for the steering wheel to be on a friction joint. So there's a compression spring there, and on the other side there, you can't quite see that, but there's a road wheel, so it's friction, and so when it gets to the end it just carries on turning, which is not very much in keeping with the steering wheel. But there's not much choice. You can't let a kid force that, they'll break it. What else do we have on this side? Well, you can see there's loads of 2-inch pulleys underneath, and on them there are heavy duty driving bands. There's a long heavy duty driving band on this side for 4 of the wheels, and a smaller driving band for just these 2 wheels. And you might wonder why it's not 3-3, and purely the reason was that I don't have enough driving bands of the right length, and when I was making this, COVID-19 was a problem, and there was just really not any easy way to get hold of any extra bands, so I decided to do it like that, which, yeah, it works fine. This needed a few designs, and yeah, at the end of the day it really did need heavy duty driving bands to provide enough friction to get this whole track to move along. There's about, I think it's 54 of these strips, and they're quite a weight, so it's quite difficult to move. At the base you can see just some sort of like runner pulleys which just keep the track in position, and that's about it for this side. So we're now on the other side, and the first thing you see is this continuously variable transmission drive here. So effectively you have 2 cones and a driving band in between each one, and the cones, as the band moves along, it provides a different ratio. So this was shown in a previous video, but there's a screwed rod here with a guide, and that as the game plays, the screw rod the guide goes over to this end, and it slowly speeds up, so that avoids having to do anything clever with the motor. The motor just has to run at a constant speed. So the drive goes along there, into there, over to there, and then finally into the drive to the track. So that's quite straightforward. This is an interesting mechanism. So we need to run this runner slowly in this direction and then quickly back to its starting point. So slowly for the game playing, and then quickly on the reset. So I've done that with 2 motors to a differential. This is a 15:1 internal ratio motor, and it's a 1:1 down to the differential, and this is 30:1, and it's 3:1 down to the differential. So the rewind is 6 times quicker than the forward, and also we don't have to worry about this motor turning while this one's turning, because there's so little friction in the mechanism that the differential doesn't transfer the power back into this motor when this one's doing the turning. And having two motors was also quite convenient for the circuitry. You know, if you only have one motor, you have to drive it at different voltages and also in reverse, so that's quite a bit of wiring and maybe relays. And I've avoided all that. I mean, the machine in total only uses 3 relays. So there are the 3 relays. I won't describe them, they're not too interesting. But this is the scoring mechanism, so you have a dial that turns, and I won't go into this that much. So there's a motor at the top which slowly turns the dial in that direction, and also at the back there's an electromagnet, so that when the game needs to reset, the electromagnet operates and disengages a gear, and it's weighted so that the dial just goes back to its sort of like 0 position, and that's your scoring dial. And that's it for the game. It should be, if the exhibition runs, at the October CellMech exhibition, but because of COVID, none of the public are going to be able to play it, which is really saddening, and it means that I will keep this constructed until the 2021 exhibition.